So far we were discussing about the waste and everything. So since it was divided into 3 different sections, one was quantification of waste from farm to fork, and then valorization and how we can reduce. So when I say reduce wastage at consumer level, who is actually a consumer? Consumer for the primary producer is a secondary processor, and for secondary or tertiary processor, consumer is human, that is household. Yeah, consumer does not mean all. We can put in a simple word called end user. Yeah, who is using at the end of a processing chain. Yeah, so ultimate end user is human for consumption purpose. Yeah, but if it is made as a fertilizer, end user becomes the plants. Yeah, so that's the way it can be looked into. So so what we were looking into about the biorefinery, how we can create stuff. So something is already well established. Seafood processing, squids, mollusks, shells is very well established. So how we can use those resources in a better way, using better what we already use. If you remember that big bioeconomy diagram, the top portion it says using better what we already use. Yeah, that is applicable to existing seafood, or unlocking the potential of seas and ocean at the bottom one. Yeah, so main focus is at the bottom one, because this is the new biomass which is not very popular in this region as well as in Europe, whereas this is yet to be explored, because a lot of different species are there, lot of different biomasses which we are not consuming, which we are not using, but they have a huge potential for different applications. Yeah, because on earth we have almost 70% water. Yeah, now what could be the valorization strategy? So if you look at this particular seafood, what we generate is both solid side stream and liquid side stream. That will be the focus of tomorrow's lecture, valorization strategies for solid side stream or liquid side stream. So liquid side stream is what we get as a liquid side stream, mainly related to water, processing water, or the water which is used for extraction purposes or for cleaning purposes. And what other liquid side stream? Can you guess? Blood. Yeah, fish also contains blood, isn't it? Yeah, think of the bigger one. Yeah, big fish, they also contains the blood. Yeah, so how that blood can also be valorized? The same thing applies for animal side of it. There is a huge amount of blood, whether it's halal process or a jhatka process, whatever way it is. So there is a blood, it has to be utilized some way or the other. Same thing applies also from the fish side of it. Yeah, some fish is consumed as a whole, and blood also contains all the nutrients, minerals, and iron and the protein. So how that can be valorized? So this is all the liquid side stream. So water, whatever is coming out of the processing, will also have some elements of blood. So that's why they have high amount of biological oxygen demand and chemical oxygen demand. So here fish, one waste is fish skin. Yeah, I've seen some people removing the fish skin by putting hot water on a salmon. The skin is removed. Am I correct in saying that? Yeah, that's very easy to remove that skin, and that skin is rich in collagen. Yeah, other one is fish muscle, the head or a tail. Yeah, or removing the scales, which is done at a domestic level also, at a processing level also. Yeah, when you go for retail or processing, there is a huge amount of biomass is collected. And then you have a fish frame, that is bones and scales, whatever is left over, or frame and bones anyway, this structure and all those bone stuff. So where we can use these bones? Fish bones. Yeah, you'll have to think yourself where we can use these bones. Yeah,
amount of calcium it is having.
Correct. Calcium extraction. What else? Have you seen the bone meal? Yeah, go on. Yeah, calcium and?
I was about to say calciums.
Yeah, correct. Yeah, calcium is a good source, bone is good source of calcium. They also have a good amount of protein, yeah. That protein is having a structural protein, and peptides obtained from such bones are very good for joint health and other one because they have those properties, yeah. Second one is if you heat all the bones to 900 to 1200 degrees Celsius, yeah, what we get? Crystalline structure of calcium, and that is, have you heard this word, hydroxyapatite? Have you heard this material? Yeah. This is a amorphous form of calcium which is used to make a prosthetic legs and different structure. Yeah. So that is another way how this type of minerals of calcium and phosphorus can be used for hydroxyapatite. So I'm not going to go into the process of that. You can look into your, you all are good in looking into the internet anyway, yeah. Just type in the word hydroxyapatite, you'll see any type of bones can be converted into that application. And that is, fish bones will have a different properties compared to hydroxyapatite formed from animal bones, or forget about the human bones anyway, because human bone goes to Ganga or in ashes, yeah. So basically ashing, that's minerals, and the minerals form amorphous structure, yeah. It's very similar when we have, okay, bit of deviation, the glass, yeah. Normal glass, how it is made?
Silica.
Silica means sand,
Sand.
yeah. Sand structure is correct, SiO4. So if you heat a sand, yeah, to what temperature you get a glass? It has to cross more than 2000 degrees Celsius, yeah, to melt silica, yeah, and then it is cooled, then you get a glassy structure. Those who have studied the plant food processing, you know starch glassy structure. You heat a starch is viscous, is translucent. When you heat it, it becomes slightly transparent, yeah, like a transparent gel. In terminology, in rheology, we use called glass transition stage, yeah, that makes a glassy transition. So silica is nothing but supercooled liquid made up of silicon, yeah. So that is what way silicon structure is changed to make a glassy structure, yeah. Same glass it is melted to make molding. If you go in any of those places where they make bottles and glasses and other ones, so this is the simple procedure used. Very similar one, when you have this calcium and other metals, when you heat it to a certain temperature, either you make a biochar, you make an activated carbon, that means to make a carbon in reduced oxygen, so it becomes black, and then you acidify it to make a activated carbon which can be used for filtration purposes. A, heat the shells or the bones to a higher temperature and it makes an amorphous structure, and when you try to filter it, it will help in filtration of water, trapment of microorganisms in the water, those type of filters which we use it in drinking water facilities, yeah. So these are some of the non-food applications of it, yeah. So we can have both food or agri-food sector. When we say agri-food sector, allied sector, because food is in the center, chemical engineer can become a food scientist, mechanical engineer can become a food scientist, but food scientist has to remain in food science, yeah. And the phrase what I use in first lecture, food science is a common science which is not so common in common people, yeah. So majority of the operation comes from the common sense. Now your crab shells, prawn shells, lobster shells, shrimp shells, and to your benefit, some of the research scholar of NIT, they have collected the shells here to do some of the practical here for you purpose. So we should be thankful to them, and we possibly will do maybe tomorrow, yeah, the practical to see how we make use of these shells, yeah, how do we dissolve these shells, yeah. So that will cover once you do the experiment, see the experiment, and then it becomes easier to apply. Yeah. Then another one is your liquid side stream, bleeding water, that is blood, processing water, wastewater during cleaning and rinsing operations. That includes the vessel cleaning as well as cleaning of the biomass, cooking and blanching liquid because you use sometimes cooked fish for salting and oil purposes, sanitary waste. So all this water goes as wastewater solid and wastewater dissolved nutrients. Yeah. So if you are trying to recover a food material, but the problem is how do you segregate the waste? Yeah. Cleaning water is one. Washing of fruit or washing of boiled potato is a potable water, whereas water used to clean the furs or the processing equipment with the chlorine and all is wash water, that is water used for cleaning purposes, and all the water in industries mixed together goes to wastewater treatment. The water which is used to wash the fish fillet or washing of the product which is for human food consumption, it is still a potable water. That means it's having all the nutrient. So if you have a clear segregation of the water, you can use that water for food ingredients. Yeah. The moment it is mixed together, then it will have to go through a certain regulation to be used for human food. Yeah. And there can be easily a debate if you use a wastewater to grow a crop or to grow certain say duckweed, seaweed or microalgae, can it be qualified as a food ingredient or not? So that means if there is a tree which gets a rainwater and there is another tree which gets a sewer water, yeah, to grow a fruit, will that fruit will be considered as a good fruit or a bad fruit? Yeah, you got my point. Yeah, because ultimately all those animal feces and all are used for biofertilizer that goes into the crop. So that is all has to go through a specific regulation depending upon what type of water is used for the production. That is also important. It used to be important how you produce a food, but in what way it is processed or produced is also equally important. You want to become a rich, but how you become a rich is also very important. Yeah, you're going through a green economy or you're going through a black economy. Yeah, so getting the product and how it is being processed, they are equally important for traceability point of view and based on socio-cultural attributes. So I'm not going to go into that. Then you have different extraction technologies. You got a brief flavor of some of the technologies, whether it's a chemical, acid alkali, deacetylation, that is again for converting chitin into chitosan, fermentation using microorganisms, that means there are certain microorganisms which can also dissolve shells, enzymatic hydrolysis, that is enzymes which can break those proteins into peptides, or chitin into chitinase, or enzyme which breaks the chitin to release a protein, or enzyme which breaks a protein to release your chitin. Yeah. Other techniques, supercritical fluid extraction. How many of you know about supercritical fluid extraction?
I know about like CO2 as a supercritical fluid. It used to extract the bioactive compounds from some plants and food matters. That extraction, the CO2 is in both levels, like liquid and gas in same time. The high pressure and high temperature used to extract the compound from the food materials.
Correct. So supercritical or subcritical stage. So how many of you use perfume or deodorants? Everybody, right? It's a liquid inside. Yeah. Even LPG gas is a liquid. Yeah. The moment we release the pressure, it becomes a gas. Yeah. Same way the CO2, if you pressurize it, becomes liquid CO2. Yeah. And the liquid CO2 is useful for extracting non-polar compound. If you have to extract water soluble vitamins, that is, you need just a water as a solvent. Yeah. When you have to get the fat soluble vitamins, so what do you need? You need a non-polar solvent. So most used non-polar solvent is hexane. Yeah. But when we use hexane as a solvent, the hexane residues are left over. Yeah. How we can get rid of hexane? What is the natural non-polar solvent which can extract your oil? If you have 2% oil or 3% oil in fish biomass left over, that also contains carotenoids, astaxanthin as some of the bioactives which are soluble in non-polar, non-water solvent. What is an alternative to hexane? Yeah. Don't worry, no petroleum ether, diethyl ether and all those are chemicals. Yeah. Hexane is much better than food grade hexane and all. Alternative to any of those chemicals, how we can get a natural one? See, diethyl ether, ester and petroleum ether and hexane, they all are organic solvents. Yeah. How we get rid of organic solvent to make a process completely green? CO2 is there, right? At what pressure and condition CO2 becomes a liquid? That becomes a chemistry question. If you pressurize a CO2, it is a liquid, and then in same pressurized condition, if it is mixed with the biomass, all the non-polar will be dissolved in liquid CO2. You take that liquid CO2, release the pressure, CO2 is gone and you get your product. Yeah, that's the simple principle of supercritical. Yeah. Apart from supercritical CO2, is there any way we can get, suppose if I want to get astaxanthin out of shells or the shrimp shells or lobster shells, to get that bioactive into a oil? Is there any way we can get that particular one without using hexane or supercritical? Any idea? Come up with a creative one, at least we'll learn something.
Deputatic solvent extraction.
Deputatic, that means having a mixture of 2-3 different solvent to get this one, right? So if suppose I have say for example coconut, coconut oil, yeah, and I want to make it a healthy oil, yeah, it itself is healthy. If you want to add astaxanthin or from shrimp shells into it, what will be the best way? One is to extract it and to add into this oil, yeah. What could be other technique? Yes, that's good.
Microwave assisted extractions, because a particular frequency can extract a particular compound from the mass.
Correct. One is solvent free extraction, yeah. How many of you have made ghee, that's called desi ghee, out of butter? If you take a milk, you have made it, yeah. How you made it? How you make it?
Sir,
Go on, yeah.
by applying heat, sir.
When you heat it, if you have seen, if you have a milk, you freeze a full fat milk and thaw it, and the moment you heat it, you will see the fat droplets on top, yeah. That means fat is present in a biomass. If you heat it, as your colleague mentioned about microwave, it will separate the lipids, yeah, because that milk is basically oil in water emulsion, yeah. So you can break that emulsion by heating or so, yeah. So one of the way is, that's same thing with ultrasonics as well, same thing with RF heating, ohmic heating or just normal heating. How we make butter? If you have a cream, you heat a cream, slowly all that oil is separated and you get your protein completely precipitated or denatured. That's the way ghee is prepared, yeah. So in a similar fashion, with the same biomass, if it is cooked and with whatever technique, whether novel thermal or novel non-thermal technique, and if you squeeze it, you can get oil clearly separated, yeah. And then it comes for deodorization, degumming, all those processes to get refined oil, yeah. whereas the virgin oil is directly extracted. So you have to see the coconut oil extraction. We all eat copra, yeah. We all eat coconut water. Same coconut is also used to get virgin coconut parachute one, yeah. So how that coconut oil is prepared? Think the similar way is a fish biomass, how you can get oil out of it, yeah. So that is what I keep saying, not only here, everywhere, to learn the translational approach, yeah. We all eat bananas. The banana is hanged from the top with the tree, and we just take the harder part, we remove it. But have you ever seen how monkeys, they eat banana? They eat other way around. The soft part they smash it and peel it like this, and the handle is used for eating banana. Yeah. So monkeys, they know better how to eat bananas, because when we eat it at the end, it always slips out. When you use it other way around, you just observe monkey how they eat a banana. That's a better way of eating bananas. They know it. Yeah. Have you seen the banana, right? You have a banana which is there in the center stalk. We always try to break it from the stalk and you just crush a bit of banana. Whereas if you reverse it, the softer portion, if you just smash it slowly, and then if you remove it and eat it, and you have full handle in your hand, and you won't drop it. And then it's easy to throw the peel as well. Yeah. So it's not that only humans teach animals. Sometimes animal teaches us as well how to make use of it. There is a story in Africa, when there is no water, they intentionally feed some of the monkeys, baboons and certain animals with the salt and all, and then they observe that particular animal, because their animal are well trained to find the water source. Yeah, that's a lot of you can see a lot of different types of video, and then animal goes in to get that particular water. Yeah, so they have different instinct compared to humans. Now coming back to the main point, all those things are there, technology and all. But have you thought of co-extraction? Most of the time you are doing extraction by using a water, deputatic solvent and other things, right? If I take a coconut oil or a sunflower oil, mix it with the shrimp shells, yeah, then use a technique or normal stirring at certain point, do you not think all the non-polar will come into the oil? Will it not? Yeah. And then remove the shells. Why extraction? We always have to think of the water and acid, put into the material, stir it, and then you get your extract. Freeze dry it or spray dry it, you get your bioactive. Yeah. Can we not do that way? Yeah. So if you take oil, and the problem with this vegetable oil is their viscosity. But the moment we heat it, its viscosity is significantly reduced. So if you take a vegetable oil, add shells to it, which contains not only shells, any of the biomass which we want to extract oil, either you add it or do the co-extraction with oil. After doing the extraction, get the oil away from the solid portion and look into the fatty acid profile of vegetable oil. You will see the addition of those bioactive into the oil. Simple method. Yeah. So what is the single most important principle of extraction? How do you extract it? What is the principle of extraction? Is one line method. Take what you want, remove what you don't want. So if you want to take something out from a bag, you take that particular stuff. To take it out, you need a specific conditions, or else remove all the bag. So always extraction is done for the targeted compound. Identify the compound, its properties. Based on that, you design your strategies. Yeah. So some are thermosensitive compounds, so you cannot use heat. Some are heat can resist a high amount of heat. Then you can apply the temperature. Yeah. That's the way we separate the protein from oil, whether it comes to butter oil, yeah, that is ghee. And then these are extraction technique. You can get protein, peptides, collagen derivatives, chitin, chitosan, enzymes, oil, polysaccharides, biofuel, minerals. And whatever the water you have can be through a membrane processing. We'll cover it again in tomorrow's lecture. And this can be used to grow microalgae, yeah, macroalgae, or duckweed. Yeah. So that was the reason of showing you those microalgae slides in the beginning when we are talking about waste valorization strategies from or quantifying waste from farm to fork. Yeah. Otherwise, it becomes slightly confusing how we get the microalgae. Yeah. Because in a given short time frame, we have to connect all the dots at the same time to link with different biomasses. Yeah. So this is one of the strategy which can be used for achieving a zero waste strategy in terms of recovery all the nutrient, and then same thing can go with the extraction technology. Yeah. So that's it was so neat and I spoiled it with all the text there. Yeah. Now, what are the current valorization strategies for different stages? One is your aquaculture. Aquaculture, that is production. Either you use a pond system, what your colleague mentioned this morning, or using a recirculating aquaculture system, that is water circulated through. What is done currently, whatever side stream? Dispose. Yeah. That's why all the area of seafood processing is having some of the smell problem. Yeah. Since there is no urban laws which says, oh, there's a smell is coming from the factory side of it. Yeah. You go in a dairy plant, you'll see some paper mills, oh, the smell is there because of paper mill. Yeah. So if those regulations are there, then you have to see how you dispose it properly so that it doesn't causes air pollution with those smell. So here is uneaten feed and sludge. These are the byproduct what we get during the production. Yeah. When it is in free water and free ocean, all these byproducts are consumed by some other microorganisms and there is a self-balancing act. Yeah. Uneaten feed and sludge, byproduct at the bottom of the system where microbes convert into less toxic material. Yeah. How we can use it for growing the bacteria or microorganisms, or how you remove through sedimentation, treatment in wastewater. Yeah. So these are the management strategy, but still the problem is how we solve this aquaculture. It's not quite easy to recover that byproduct and valorize it because these are in aquaculture system. Yeah. So that's why new strategies are coming up for production system. One of them was IMTA, because some of those byproduct can be utilized by other species. Yeah. That's why integrated multi-trophic aquaculture system is coming in place, and within that there is also organic certification. That means whatever is produced is organic in nature. Yeah. Because of different system and no chemicals or pesticides used. Second one is fishing. Yeah. That is, one was fishing means wild harvest. No treatment, dispose, mainly bycatches, return of dead catch to the sea. Yeah. So that is still not advisable. Then again you are disturbing the ecosystem. Fish meal production. So whatever bycatches you are getting, you can make a fish meal. Applicable also for bycatches, that is production of fish meal in processing plants required for aquatic feed product. So whatever fish, small and bycatches, if you cook it to 70 to 80 degrees Celsius, yeah, whole of the fish as a biomass, either you centrifuge it or you squeeze it, you get all your oil. As what you mentioned about microwave, you can cook it using microwave or you can cook it normal cooking process. When oil is removed, whatever is left over, if you dry it, you get a fish meal. Yeah. Think if fish contains 14% protein, yeah, 70% moisture, just leave it only these two figures. Yeah. Makes it at the moment how much? 84, 85%. Yeah. And suppose 10% lipid, rest is ash. If this biomass is dried completely with the 2% moisture, what will be a protein content then? It will cross more than 50%. Yeah. When you extract a fish protein, if you get 60%, so simple strategy is to dry a fish, grind it, use a particle size separator. Fine particles will be all your protein, coarse particle will be bones and scales which are not grounded. Yeah. That is called dry way of extracting protein. Your colleague who is extracting protein from pulses, yeah, is a dry fractionation or a wet fractionation. In dry fractionation, there is another technique called air classification. That means you make very, very fine flour and then you have air cutters which separate the starch, protein and fiber based on their densities. Yeah, that's other way of classification. So if you are drying, if you're making a meal of the whole fish meal, you get your oil out by squeezing, then oil and moisture is reduced, then you have your fish meal with good amount of protein in it. Then that particular biomass, dried biomass, can be used for production of your peptides or to obtain a purified protein. Yeah. So you design your extraction strategy based on what is intended application. Yeah. Otherwise, protein extraction from fish is very straightforward. There is not much required. You have a fish biomass, you add an alkali, within 10 minutes all the protein will be solubilized in alkali. Yeah. And then you use acid to precipitate a protein and you get 70 to 80% protein from fish. Very straightforward procedure. Yeah. Similar process is used for alkaline protein extraction from cereals and pulses. Yeah. Anybody want to add anything to that? If you want to make it complicated, you can make it complicated. You have to increase efficiency by using ultrasonics and all. Yes, that can be done. But in order to use a technology or any process, which is important for you all to understand what is the basic process first. Yeah. I have seen lot of work is being carried out for fortification of bread with A flour, with B flour or C flour. And then you compare, we can replace wheat flour with 5% of tomato flour, banana flour, whatever you want to call it as. Yeah. But before making fortified bread, learn how to make a bread. Yeah. That is the biggest challenge. Once you know the common process, in order to extract chitosan with microwave, ultrasound or whatever technique, first do the normal extraction and then to see where you can use the technology. It's a single step extraction, that's okay. But if you have multiple stages of extraction, what you will see in the coming lectures, then you have to run a control process and to see where all you can improve the efficiency. Grinding can do the job to improve the extraction. Yeah. Same thing for extracting oil from sunflower or canola or mustard seed. You have a seed, you put it into a small bit of water. You have seen a farmer, like, what do you call that? Kolhu ka bell. Have you heard of this word, kolhu? Yeah. How the oil is extracted in villages and farms. Not the machine, kachi ghani, even like KTC is there in KTC in Kerala. They extract lot of oil, they export it to Europe. Yeah. How oil is extracted? You have the seeds, you press it, either hand pounding and you press it, you get your oil extracted. Yeah. But in order to improve the efficiency, you sometimes toast it. Yeah. Or grind it to improve the efficiency. And then other one are supercritical and all. So what happens? We always think at fourth level solutions, but majority of the solution can be achieved at lower level itself. Yeah. Technology is there, but to be used based on the requirement. Now coming back to this fertilizer production. So fish meal is one of the most low hanging fruit which can be produced, and same fish meal can go for pet food industry or for feed industry, including it will leftover oil is providing your essential oils and everything. Yeah. And then if you are making a fish meal from whole fish, then it can be used directly for food application. Leftover biomass and other element can go for pet food, animal feed, or for fertilizer production or liquid or solid fertilizer, silage, that means using that biomass into acidified environment is the silage, yeah, or compost through fermentation. Other one is mitigation, that is prevention. The famous saying, prevention is better than cure. So, how you can avoid bycatches? So, you make your, if you are targeting cod, for example, cod is a big fish, or you are targeting a mackerel, why you want to use a smaller mesh size? You can have a bigger mesh size, yeah, so that small fish are not caught. So, that is what it means by mesh size, yeah. Use of fish eye devices. There are a lot of techniques are there which focuses or only captures specific type of fish and let go other fish, yeah. Implementation of circular hook or alternative bait in long line fisheries. Only use a bait that is which attracts a specific type of fish, yeah. Make sense? Or improvement in remote sensing and animal tracking technologies, drone and all those AI mediated systems, all these things can be, yeah. So that means how you can avoid bycatches. If you cannot avoid it, you have to make use of it, yeah. Does it all make sense? Is it easily said than done, yeah. So the best part here itself is when you are harvesting it, because there is also a problem. Harvesting of fish is done by A agency and processing is done by B. So their target is only to harvest maximum what they can and hand over to the processor. Since there is no regulation about bycatches, the moment regulation comes in, whatever you are harvesting from the sea, you cannot dump it back to the sea. If you regulate it, then you will focus on these type of processes. But even whatever bycatches are coming, and if you make a simple process of making fish meal, it will add to the economic benefit of fishermen, yeah, and then they can sell that particular product in a market. For instance, if you go in some of the supermarkets, you have seen like rose mix as a fertilizer, yeah. Buy it and analyze it. It's a chicken litter, yeah. Cactus powder, what is it? Broken bricks powder, yeah. So this is all our innovative way of selling it. Or if you have that same water coming on the fish side of it, contains liquid nitrogen and different minerals, that is sterilized, packed and sold as a liquid fertilizer, yeah. Now, processing. 2 stages. One, don't do anything, no treatment, dispose head, bones, offal and skin. Quite common practice. Here processing could be at HORAC sector, that is hospitality and catering businesses. Waste is eliminated through its discharge into ocean or is disposed in landfills, yeah. We do this maximum time, yeah. Other one is valorisation, that is using a biorefining technique, get solid and liquid waste and extract high value ingredient, and this is the focus what we'll have for next couple of lectures. Other, consumption. So this is the question for you guys, how we can reduce wastage at consumption level because you are a consumers, or how we can valorize it at a consumer level. This is even more challenging, yeah. So that means you have to segregate organic, inorganic waste, but within organic you have a plant and animal. How do you do those segregations, yeah? And that could be very, very interesting project, interesting ideas, which you have some ideas you can propose. Government is currently very promising. They do promote new businesses to startups, and a lot of talent pools are there, as what I hear. And you come up with that strategy, and you'll solve not only the problem, but at the same time establish your business, yeah. And required scientific knowledge you already have. You don't have to read more books and papers to get to that one, yeah. And this is all what you see is from one of the publication which is authored by our Irish Seafood Board, that is known as Board Ishq Mara. But this is not the Ishq what you see in a movie. That's the way it's an Irish word, BIM.IE. That is Irish Seafood Board. Yeah. So this is all different strategies, whatever is done, and you can look into that particular website which talks about different projects, different valorization strategies, and what they do with lot of fishermen, aquaculture, and different farmers. So now coming back to solid side stream and liquid side stream, and you will be seeing this particular slide tomorrow again when we go for liquid and solid side stream. So this is again rough estimates how much are the solid, yeah. Overnight when you have a time, just think how we can make use of it, segregate it and get different product. Get the tangible one, not the book knowledge. We can get the chitin, we can get a collagen, but how we can get it. Again, when it comes to water, that is washing water, blood, waste brine if you are brining the meat, cooking water, drying water and fillet, yeah. And then if you'll see all the fish waste, water, carbohydrate less than 1 because it doesn't contain much of carbohydrate. Whatever carbohydrate is also because of the digesta and what is there in their stomach, protein, fish, classified lean fish, that is less amount of fat, or fatty fish. How many of you have seen cod liver oil? Yeah. How it is extracted? Liver is a byproduct. Yeah. So popular, isn't it? Very expensive oil. Yeah. So same way cod liver oil is there. Why we can't have a mackerel liver oil and all, right? So basically it contains specific type of fatty acids what we briefly touched in the beginning, and all these oils can be easily segregated, fractionated to have number of different products. So this particular slide you will see tomorrow again when we go into details of side streams. Yeah. Now this is a seafood processing chain. So you have a fish, yeah, bycatch, whatever, transportation. This is normal bycatches which are obtained based on current production facilities or current mesh size, and then once it is processed, filleted, that means you remove this portion or you remove this portion, yeah. This byproduct generation could be ranging from 20 to 70%, yeah. That also depends upon your automation level. If it's normal automation, you are only cutting this middle portion. If fish is big, yeah, if you don't have a proper grading, you have more losses or more byproducts, yeah. But remember, the logic is even this portion of a fish, how we used to draw fish, yeah, I can make eyes as well, right? This is fish, yeah. If you cut this portion and this portion is used for filleting purpose, composition of this portion meat or muscle will be same as here and here, right? So byproduct is having the same value in terms of protein and composition compared to rest of the material. Do you all agree with that? Yeah? Because same type of muscle, but obviously composition bit are different. And then you fillet it. Then you get fish scale, blood and sludge byproduct. And this byproduct goes as at the moment as a landfill or is disposed. And this is low hanging fruit where you can extract your different ingredients out of it, and very simple process which we'll try to go through with different techniques, technologies, valorization approaches. And other one is this fillet goes for different type of processing to produce products, yeah. Fish cakes, you have fish fillets, ready to eat, RTE, that is ready to eat food products, RTP, that is ready to process, and I'll add new word, RTC, ready to consume, yeah? There's no point in making RTD, ready to digest, yeah? So basically all these different product, then you increase level of processing, and during all these processes, you get your commercial food product, yeah? Commercial food product, and you have a wastewater, yeah? Correct? And how we make use of this wastewater, either processing wastewater or solid waste. So yesterday when we are going through on the case study, I showed you a fish, different product coming out of the fish, fillet, sausages, another one, and then you have a different ingredients, and then you have a water valorization, yeah? So how these different things are interrelated, and an important aspect is when they are interrelated, so we have to always go back and come back to the new stuff. Something like you are reading a book, a lot of abbreviations are used. So every time you go to the first page to see, oh, what does it mean? And then you go back to the lecture or go back to the chapter. Similar thing happens in this particular lecture moving forward. We'll be going to and fro. I'll try to calibrate all those, some of the older slides into it, so that we get our refreshing, we get refreshed with what we have studied or gone through previously. Now again, waste generated, aquaculture or capture fish, bycatches, on-board storage, on-board handling. So these are the technique which are required for reducing the wastage, yeah? Frozen storage, chemical preservation or different stuff. For capture, yeah? Aquaculture, how best you have post-harvest handling facilities, sludge and fish mortality. That means when you are doing aquaculture production, one of the big challenge is mortality of fish. If there is any disease in a fish, how that can be spread and how you control it. Then again it comes with your antibiotic and chemicals used. Then again we are adding another issue with aquaculture, right? So aquaculture is better than wild harvesting, but it's having its own challenges, yeah? And in some cases, to reduce this mortality, have you heard of lumpfish? Is also known as cullfish. These are very small tiny fish which is injected with, which is vaccinated. Each and every fish is vaccinated, and it is used in salmon farm to eat lices which are there on the big fish. With the mackerel, salmon, all the lices which are also known as lump suckers, to eat those lices till the time they are 100 grams, and after that they stop eating those lices, and those fish are released in the water and they grow as big as few kgs. It can go up to 10 kgs or 15 kgs, or we call it as a cull fish. When their job is done, those small fish are removed. They are, cull means killed, yeah? But that are also can be valorized for different product. The argument of culling is because they eat lices, so they are not fit for human consumption. You can agree with this argument, you can disagree with this argument. In that case, chicken which eats all the insects should not be consumed, yeah? So that's the logic, because leave the chicken eats all the insects, yeah? And all this whatever chicken curry, chicken, butter chicken, all those chicken 65, all those ingredients are there, yeah? Then we should not be consuming that particular chicken, yeah? Because chicken is produced by consuming insects. So that's the name it gets from lumpfish. And this is one of the biological way of removing your lices from salmon farm, yeah? So that is all how different storage. If you Google your cullfish or lumpfish, you can see how they are grown and where they can be used in aquaculture system, yeah? Have you heard about this lumpfish before? It is quite prominent in England, Scotland and Ireland. It's produced and is sold. It's quite expensive, and each and every small tiny fish is hand vaccinated, and they need around more than 50,000 or 100,000 of those fish. Each and every fish is individually vaccinated so that they do not get a disease and spread it into aquaculture farm. Yeah. There is a saying, you know, one fish spoils everything. Yeah. Same way, how do you control the fish mortality is an important one. Same thing, mortality issues are also with mussels, yeah, as well as other things, because you can't go and check the disease, yeah, in aquaculture, because it's a standalone. You don't go there, it has to have a way of checking it, yeah. So every new technology will have its own caveats which has to be addressed. Now then, when it comes to processing and storage, fresh fish, you are drying, smoking, salting, canning, yeah, freezing, salting, again you have a byproduct, and wastewater. This is a rough estimate of wastewater what is generated per kg of fish. For every 100 kg of sardine, we need at least 1000 meter cube of water to be processed. So amount of water required for each and every operation, you can quantify that water required, yeah. So that's why one of the biggest strategy or requirement from the industry is how to reduce the utilization of water from the processing chain. That means how we can reduce the water or reuse the water, yeah. If the water coming from here can be used for washing of equipment or to reuse the water, because water is a precious commodity, and then retail, and then 10 tons, then you lose 3 to 3.5 ton on board line processing and retail. So it shows how much losses can occur. So all these values are different. Need not to remember those values, just remember approximately how much losses happens. Yeah. 100 kg of fish, if you have to extract a protein, maximum protein what you can get is 14% out of it, yeah, that too on a fresh basis. So that's why material balance is important, to know what all you can obtain, then only you can make an economic value of it, then only you can propose a solution. So what we all work on is specific unit operation, but we have to make a full process and then worry about transportation of those processes. The one what I was talking about, that BIM paper, is from Journal of Cleaner Production, 392/15/2023, and you can see exactly the same figures over there, yeah. And there is a couple of chapters and our own books are there which also mentions pretty much similar stuff. And now if you see high added value product, pharmaceutical, cosmetics, biotechnology, you have seen the diagram in the seaweed as well, food, animal feed, fertilizer, energy. That means what all you can get out of it, that is collagen, chitosan, gelatin, different side streams, protein, hydrosolate, oils, pigments, fish meal, that is fish meal flour, that is making a flour out of fish, fish oil, protein hydrosolates or protein concentrate. So assignment for you tomorrow, I'll ask a question, what is the difference between protein isolate, protein concentrate and protein hydrosolate, yeah. What is, and dairy people, they know, they should be knowing this definition very clearly, yeah. And what is a protein rich? When you say about alternative protein, fish contains only 14% protein, yeah, correct. Egg contains 4 or 5% protein, or milk contains 3 or 4% protein, whereas wheat contains 12% protein. But why egg protein is better than wheat protein, yeah. And that's a big word, yeah. Why bioavailability of egg protein is better or fish protein is better than wheat? Even if you mix wheat with dal or rice with pulses, you get all your amino acids, yeah? Very simple, you know, because we are animal and these are also animal. So animal protein will match animal, yeah? That does not mean if you eat a human meat, it will have a better bioavailability. It's just because the configuration is the same, yeah? When we go for it's just a logic one. You agree or you disagree. Either convince me or get convinced. So when we get a plastic surgery, so we use the skin or we get what you call a bypass surgery. Vein is taken from your own body, is not taken from some other person's body. Yeah. Same way there are plant kingdom and animal kingdom. That's the way system has been divided. Yeah. So that is why it's having a better utilization on human system. Yeah. So that's why it's, and other things are about amino acid profiles and everything. Yeah. And these are readily digestible ones because they are ready. You can, even if it's raw is eaten, it's still perfectly fine. But whereas raw grains are eaten, they have to be processed in different manner. So coming back to this one, is waste from the byproduct of interest in a circular economy strategy to add value to the end product and achieve zero waste. This is very famous triangle, yeah? Waste not, want not, recycle, reuse, repair, and all those words are there, yeah? But when it comes to actual practice, it is quite challenging, yeah? So if you do it, then you will have completely different idea, yeah? Because I do know to use different enzymatic pathways, supercritical ultrasound, fermentation, microwave. What are the challenges? It's easy to do it in 100 grams, 200 grams. When we are talking about the tons, yeah, tons of fish harvested, how you are going to do that, yeah? Scale up of processes, scale up of technology is a biggest challenge, and then adopting those processes at commercial scale is another challenge, and then convincing the industry to adopt those changes plus the regulatory aspect is another challenge, yeah? So technology, we throw out a lot of technology, but if you see certain sectors, they make a technology, oh, let's get this centrifuge technology from Russia or cryogenic engine technology from other places. It is not in a lab, it's at the existing commercial level, yeah? That means it's an operational, everything is being tested, risk assessment and SOPs, everything is there, and then you do adopt it, yeah? So there are a lot of challenges are there. So how we develop that particular process, how we make a simple enzymatic processes from fish waste to produce a 1 ton of protein, yeah? Think of the volume, yeah? So food waste by supply chain, these are EPA figures, yeah? That's why it's very less in amount. From Irish figures, primary production losses 53k, manufacturing process 230, retail and distribution 90, restaurant food services 157, household 220, total amount of wastage, yeah? So here food loss or food waste is integrated together, yeah? So you can quantify that. If I would have quantified all the waste from each and every sector, we must be talking about the percentages, and that yields nothing apart from having an information, yeah? Think of any of the biomass, if 100 kg is processed, what are the side streams they are obtained using that famous circular diagram? What is the quantity and what is the best way to extract first, yeah? And then to go to the next level, yeah? That means systematic extraction, that is known as biorefining, that is refining step by step, yeah? So again, one was reduce and to transform, yeah? So that means using better what we already use, unlocking the potential of seas and ocean, that is using well what we don't use it yet, yeah? At least after 10 days, at least this figure will be very well clear to you all, yeah? At least there will be some take home message. So this particular diagram, and to see what is already existing, how we make a best one, learning from those mistakes, whatever new biomass is, how we develop process so that we don't have to alter it. Yeah, it's something like when road is built by A agency, then a telephone company comes in, digs the road and put another pipe, and then there's a patchwork there. Yeah. But if you would have done in a first stage planning of the city, yeah, then we don't need to do that. Yeah, or else to rebuild a drainage system. That's why there are certain cities are called planned cities. Can you name a planned city? Chandigarh. Yeah, there are different sectors. University campuses, they are very well structured. You know what, where is the house, or where is the water drainage, what is the wastewater treatment, everything is very well planned. Or you have a piece of land, you just make some houses randomly and then try to connect the distribution system. So this is what, using better what we already use, or to build a new city that is for new biomass, how we valorize every fraction of it. Yeah. Now, what could be the strategies for waste at consumer end? That is prevention or minimizing. Yeah. Embedding low food loss or waste practices, sustainable intensification, disrupting the food production dynamics. That means whatever is current dynamics is to try to change the practices to reduce the wastage. So in order to suggest any waste reduction strategy at production or at processing, you have to go and visit the site and see what is done, and then think and come up with the solution, propose it to the industry person, then say, no, we are not doing this because of A, B and C. Yeah. When something is being done or is not being adopted because of some new reason, if you get a new idea, there are only two possibilities. One, nobody thought about it, or somebody thought about it and it didn't work. Yeah. So if you do discuss that idea and then you say, no, we did try but it didn't work because of A, B or C, but you may have a solution for A, B or C. Yeah. So that's the only way. What it means: objective, goals, adoption of low food loss or waste practices, infrastructure, as you mentioned about the cold chain and all, that's done at larger scale. Stakeholder collaboration, that is stakeholder, that means all the people who are involved in that particular one. Trade through short value chain, if the producer is a processor, yeah, so you are eliminating the distribution and losses. Increase the capacity for food processing, that's why a lot of food parks and everything is getting established, different locations. And sharing of support for food loss and waste, that means if a company is able to reduce it, how those practices can be shared. So there comes the trade and intellectual property rights, yeah, so that those informations are freely available so that other people can adopt it. Because of that, industry, academia collaboration, international projects happens to have to share the best practices. Yeah. And then policy actions, that means you design different policies, and this is the area which I'm not so happy with to go in, because making a policy is easy, implementation of those policies is difficult. Can you name a policy which is very easy to say and very difficult to implement? Honesty is the best policy. Yeah, this is what we have been hearing right from the childhood. It's very difficult to implement it. Yeah. So then, going back to the same waste hierarchy, most preferred option is to prevent the food losses and waste. Whatever is there, to reuse it for human consumption. What cannot be used for human consumption is use it for animal feed. Yeah. But nowadays feed regulations are much more stricter than food regulations. Pet food industry, pet food is more expensive than, in some cases, human food. Yeah. And pet food sector was always considered as recession free business, because people, they can reduce their consumption but they will definitely feed their pets, and with that too with high quality feeding material. I can give you numerous examples. Couple of companies from America were with us. They wanted to use certain technology to improve feed quality. And if you do the microbial assessment, quality assessment of animal feed, what is sold in a market, and the food, you'll see they are much more microbiologically stable compared to human food. Yeah. Recycle and reuse. Recycle for nutrient recovery. This is what we'll go through for microalgae cultivation, macroalgae cultivation, or duckweed cultivation. Leftover recover energy in a form of anaerobic digester, biogas, methane production, and then biofertilizer. Last one is to dispose. Yeah. So this is again European Commission Joint Research Center. That is again, it's a European wide policy, and you would have seen even the similar type of diagrams in some of the multinational companies. What is their waste charter or waste reduction strategies? Yeah. If you go to the hotel, it says we do not clean your room every day or towels every day. If you want to get it cleaned, put it at one side. Yeah. Just because they wanted to reduce the usage of detergents and water. Yeah. So different sustainability agendas are there. Now, same thing when it comes to fish. You have high value product, low value product. Its triangle is inversed. Yeah. What other is the difference here? What is the difference between this and this? This is general purpose. Yeah. When it comes to meat and fish, there is another issue of category. That is high risk product, medium risk, or low risk. Yeah. You would have heard mad cow disease. Yeah. Right. So when we are dealing with muscle food or high risk food product, and these are the one which can carry the foodborne pathogens, botulinum and all those things, and which is very, very high risk, and it has to be disposed. Yeah. That means it has to be incinerated. If there is a dead animal, it cannot be valorized. Even though if you're valorizing it, it has to be incinerated. All this COVID virus, we all know all those stories. Yeah. So that's why it becomes quite tricky when it comes to different categories of waste. Yeah. So, and it is not that you have high risk, you have to dispose only, but still there can be a valorization strategy related to that. So, all this remains the same. Yeah. The only difference between the previous one and this one, this is upside down. Yeah. If that was M, Mohan's mother, and then it becomes Mohan's wife. Yeah. Triangle is upside down. The only difference is this is related to high risk meat products or muscle food. Yeah. Oh, sorry. So when it comes to fish loss and waste, primary production, value chains, different activities related to that. Post production, landing, handling, storage and transportation. Processing, cutting, drying, fermentation, salting, different steps. Yeah. Distribution, retail and trade, and consumption, storage, preparation and table. That means that is only way how we can reduce our wastage. Primary, post production, causes of food loss and waste, and I'll give you the reference of this particular book chapter which you can read it, and this is written by us and our colleagues. And processing and cause of losses, distribution, loss and waste, and consumption. So it's pretty much the same thing in a different formats. Yeah. So what is the take home message? How we reduce wastage. Yeah. So tomorrow will or what we have covered so far, all different types of waste, side streams, whatever is obtained, and how we can create a value chain. As you'll see, lecture number 17, 18 are all related to value chain creation coming from the side stream or the product made out of those ingredients, and how those ingredients can be extracted, and how we can come up with integrated biorefinery system that will be covering from tomorrow for solid waste, liquid waste and production of biomasses, that is duckweed production, microalgae production, macroalgae production. Yeah. So some of the boring stuff is already been covered, so it will be something what you will see. Yeah. And what we have covered so far, how do we first quantify the waste along the chain? That's very important. Yeah. Quantification and classification of waste. Yeah. That means whatever waste is generated along the chain, you need to classify what are the type of waste, category of that waste, if it be high risk or low risk, and what can be used, and then how that particular stream can be converted into different ingredients and food and feed purposes. Yeah. And we'll go into depth of this tomorrow onwards. Yeah.